Good morning, everyone, for attending these trainings. Okay, first of all, I would like to thank TDRA for organizing this event and giving Huawei the opportunity to present the topic of IoT concept and applications. Okay, first of all, okay, let's have a look what is the IoT. Okay, before we start on the topic about this IoT, first things we need to know is what is the IoT. Okay, so for the current new generations of the information technology and the development phase in this information era, IoT plays an important role for enabling all these developments. Cool. So you can see that IoT is currently widely used in the network convergence by converging communications and sensing technology, such as intelligent sensing, identifications, and pervasive computing. Therefore, this IoT is also called as the third wave of global information industry developments after computers and internet. Okay, so for today, after you completing for these trainings, you'll be able to understand about the basic concept of the IoT, and we'll discuss an overview of this LPWA technology as well. And we'll give some example related to the IoT applications and the use case. Okay, now let's have looks on the basic concept of the IoT. Okay, so for this IoT, the concept is not something new in the current era, but actually it was first discussed by the MIT in year 1991. Okay, just that at the early phase of the IoT is mainly based on the RFID technology, where it's not that much just compared to the current phase. And based on the agreed communications protocol and the internet, they would like to realize the intelligence identifications and also the management, informations interconnections, and the exchange. So if we put it to a simple way, will be we would like to connect all the devices surround to the internet. Okay, so when we're going for the IoT, we are changing from the internet of people to the internet of things. Okay, in the previous phrase, we are more on like connecting. Okay, so we also call it as the internet of peoples. But in the current phase of the IoT, it's more on connecting on the devices or the things, okay, into the internet. That's why it's also called as the Internet of Things. So they will implement with the microchips inside your devices to enable the communications or some kind like the talk. Okay, you can talk with your devices or you can communicate with your devices. Okay, so for this IoT, actually there are many applications and use case in the real scenario. Okay, so when we are entering on this intelligence era, we are like using all your things, they will connect. So in order for the thing is connected, we'll call it as the all things are sensing, meaning that all the devices they will have the capability on sensing the informations and provide these informations to you. So we also call it as the all things sensing, and is connected to the internet through the pipe, and also called as the all things connected. And the last part, which is very important, will be all things intelligence. After we collect all these informations into the cloud, in fact, the most important things will be how we use these informations to interpret into useful informations for us. So that's why we also call it as the all things intelligence. So we can see it from these two perspectives. One is the sensing, second will be the connected, and the third will be the intelligence. Okay. And if we base on the studies from the IDC and the Huawei research, we will notice that the IoT is currently leading the vertical industry innovations and the transformations. And you'll notice that based on the studies, we notice that there are 60% of the organizations, and might be more than that, that are using and implementing the IoT services. Okay, and 24% of this company IT budgets are allocated mainly for the IoT implementations and the development as well. And 63% of these IoT adopters, they notice that they are seeing a significant return in their investments in this IoT. Okay, and this IoT, it become a service. So you notice that in the industry, sometimes they also call it as the IoT as a service. And you notice that 90% or more than that of the business, they will store their IoT data and the applications in the cloud. And followed by they were using the applications or sometimes like the big data, how to convert these informations to improve on the applications or the business point of view. And if generally for the IoT, mostly will apply in the utility. Example, we have around 3.6 billion of these connections that use in the utility. And another good applications of this IoT will be in the smart city. I believe you heard about this smart city before. And we are expecting have around 6.2 billion connections in the smart city applications and 1.6 billion connections mainly for the vehicle, which is the IOV. And while for the home applications, maybe around 1.1 billion. Okay, and actually there are few more applications named on, such as like the track and the trace. We know that now the online shopping is getting more popular due to the pandemic. So these figures might be more than 2.5 billion in the current stage. And the other applications will be like the retail, health applications, and in some of the buildings like the elevator. Okay, we can see a wide range of the applications for the IoT. It's not limited to the applications that we listed down over here, but there are much more applications that we can use through the IoT. Okay. Before we go to the next part, first thing when we see on this IoT, you might think that in fact how they work, how can we transform or transfer the information from the devices into something is useful for us. So we can see it from one IoT end-to-end network architecture from four perspectives. So we have the first one, which is called the terminal, equipped with the sensor, or we can also call it as a sensing as well. So this terminals is not limited to like your phone, but actually it's applied to like you can use it for the smart meters, your home appliance, or we can use it for the cameras with the IoT cameras, some of the wearables, vehicles, or any others the robots that we use in the industry as well. So all of this one we can call it as the terminal. Okay, so this terminal is the one that equipped with these microprocessors that can report these informations or the sensing informations to us. So through the terminals, they will transfer the informations to the network. Okay, then now here's the important part. How can we transfer? Okay, what type of the technology we can use to transfer the informations from the terminals into the network? Okay, there are two main options we can use for communicating. First one we have is the mobile network. So first things, first part, we have the mobile network, which is like the, maybe you know about like your phone that you're currently using, which is the mobile network, 2G, 3G, LTE, or we have the specific applications, ELTE and BLT that use for the IoT, or in the current latest technology, which is the 5G. Okay, so here for the first options will be the mobile network, followed by the second options we can choose the the agile IoT gateway or the smart home gateway, whether it's through the fixed networks or we can use the wireless as well. So for the network, it play an important role on transferring your information towards your IoT platform. Well, for the IoT platform, the main the main objective is to provide the connections management. It will collect all your information, which is also called as a big data, and provide the operations support. And from this IoT management platform, we can transfer the informations or some kind like process the informations to be used by the applications like the public utility, industry 4.0, okay, which is the current industry's development, and then smart home applications or some green energy as well. Okay, so here from the IoT end-to-end network architecture, you can see it from four perspectives: terminal, network, platform, and applications. So from these four layer, we can expand it to the more details about the actual implementations. But of course, there is one part that play and very crucial part will be the IoT security. So for the security, it's very important for the IoT because now we are involved in about reporting the information towards the platform. So the IoT security is another important role that play inside the whole architecture. So for this IoT security, it will involve not only on the network, but actually it's starting from the terminals. We have the terminal security, your IoT firewall, okay, which is involved in the network, and followed by in your platform, you have your big data security protection as well. So this IoT security will be very important when we implement the IoT network. So for the end-to-end network architectures will be terminal, network, platform, applications, and of course, that deployed together with them will be the IoT security. Okay. So just now will be some basic introductions for the IoT concept. And now we're going to have a look about the LPWA technology, which is sit on the network part. Okay, just now if you still remember, we mentioned that for the network, we can divide into like wireless network or the mobile network plus a fixed network. Okay, for the LPWA, it belongs to the wireless network. Okay, why wireless network will be used mainly in the IoT network is due to the cost of the implementations compared to the fixed network. And when we go for the wireless network, will be much more easy in terms of the whole deployment phase. So the whole durations and the cost that will involve for the deployment will be faster and cheaper if we compare to by using the fixed network. Okay, and LPWA is one of the technology we can use in the IoT network. Okay. So when we go for this wireless communications technology that I mentioned, we can use it in the IoT. In fact, we can divide them into three perspectives. Okay, first one will be the cellular mobile networks, which is just now I mentioned. We have like the 2G network, we have the 3G network, LTE, or the latest, we have the 5G. So the ones considered under the cellular mobile networks. Okay, while another options will be the short-range wireless communications technology. I believe you're familiar with it as well. Will be like Bluetooth, okay, and then we have like the Zigbee, okay, Z-Wave. The ones considered for the short-range wireless communications. And for the third, which is we're going to discuss today, will be the LPWA, which stands for the low power wide area communications. And for the LPWA, in fact, we have few options can be used for the deployments as well. Okay, so for today, I will going to discuss what's the options that we can use for the LPWA. Okay, so meaning that for the companies or the vendor, if you like to implements or deploy the IoT network, they have few options. Okay, either using the cellular networks, or they can use with deploy with the short range wireless communications technology, or the last option will be the LPWA. We can see on their requirements and the applications that we can choose a suitable technology to deploy for the IoT network. Okay, first things, when mentions on the LPWA, there is one option called Sigfox. Okay, actually for this Sigfox networks, they use the ultra narrow band technology. Okay, and this technology, because it's using the unlicensed, okay, this is very important. They're using the unlicensed spectrum where the web, the company no need to pay for the frequency band that they are using. So unlike the mobile network, they need to their license or the spectrum that they deploy is the license, meaning that they need to pay the money to the government in order to use the frequency band. So if the company deploy the IoT by using the LPWA, example through the Sigfox, they don't need to pay for the frequency band they use to deploy. Okay, and for the Sigfox, other than they are using the unlicensed band, another benefit will be their power consumption is very low. Okay, we know the power consumption is very important when we go for the IoT because we're going to connect a lot of the devices to the network. And if these devices consume a high power, then it will be another cost for us. So the low power consumption is very important. And the next thing is for the LPWA is they're using the unlicensed radio frequency band, like in the Sigfox. And the frequency range used in the Sigfox is very depends on different country because each of the country they have their own laws and the regulations about the spectrums. Like example, in the Europe, most of them they deploy the Sigfox using the 868 megahertz frequency range, while in the United States they deploy in the 950 megahertz frequency band. Okay, and for this Sigfox, they adopt the ultra narrow band modulations technology, where the benefit of this technology, the signals can penetrate or transmit over a distance like 100 kilometer or 1000 kilometer. But in the 1000 kilometer will be under their testings. Um, so in the actual applications, if you if you imagine that for a 10 kilometer or 100 kilometers is a very cost effective way to deploy it, the IoT with the Sigfox. But of course, you need to see, we'll have other considerations as well when we want to choose a suitable this technology for the IoT network. Okay. So if your signals can penetrate for a very long distance or transmit for a very long distance, we'll require lesser base stations to support uh, for the whole IoT network. Okay, you just imagine that now if my one base stations can provide 100 kilometers, that throughout the nationwide coverage, I will require definitely less than that. Okay, maybe one or two base stations now. Okay, so that one is a more cost effective, mainly for the IoT network. Okay, so this IoT network, uh, through the Sigfox, we will use it mainly if we prefer a free frequency bands and a small power consumptions. So the whole network architecture can say that is simplified under the Sigfox solutions. Okay. Other than the Sigfox, we have another options called the LoRa. Okay, LoRa is stand for the long range, which is under the LoRa Alliance. There's a one alliance to develop on these specifications for the LoRa. Okay, so for LoRa, they're more on the physical layer based technology. They are implements on this data communications through this network, and their protocol is maintained and managed by the LoRa Alliance. Okay, and for this LoRa technology, they can support for bidirectional. Okay, bidirectional means that I can send and receive. So that's called bidirectional. Okay, because some of the IoT application, they might just require a, a single direction or unidirection. You are just required to report, but you don't need to receive anything from the network. Okay, so this was if your applications require a bidirectional communications, then LoRa will be another option, because for this LoRa, they can support for the bidirectionals and they comply with a series of the open source standard. Okay, and specific solutions for this LoRa network we also call as the LoRa WAN, which is a wide area network. Okay, and for this technology actually is developed by the Syntec and supported by the IBM. Okay, so for this LoRa, uh, mostly they are uses for the like automatic meter readings, smart home appliance, or some of the automations in some building applications. Okay, another one can be like the wireless security system and the industrial monitoring. So the applications for the LoRa actually is quite wide as well. Okay, and another good thing of the LoRa will be they use the unlicensed spectrum, just like the 6-fox. Now we have a look on the third options for the LPWA. Okay, under the another options for the LPWA will be the NB-IoT. I believe you heard about this term before, NB-IoT. In fact, NB-IoT is belongs to the cellular as well because it's deployed based on the LTE network. Okay, we deploy from the LTE network to implement the NB-IoT. Okay, so for the NB-IoT, in fact, they required or they deployed on the licensed spectrum. Okay, just that for the NB-IoT applications, they only require a very small bandwidth, which is 180 kilohertz. Okay, and you might notice that some of the operator or this operator that provide the options for this NB-IoT mainly is like they use some of the LTE spectrum to deploy for the NB-IoT, meaning that it will be more cost effective for the operator if they would like to provide the IoT network to the user. Okay, because they can base on their existing infrastructure to deploy the IoT. Okay, so for the NB-IoT will be more suitable if the company like the operator, they would like to deploy for the IoT network. They can base on the existing network to upgrade it to the NB-IoT. Okay, and for this NB-IoT, a good thing will be because they are comply with the 3GPP protocol under the release 14. So for this NB-IoT, they support for the base stations positionings and also for the mobility. Okay, the mobility means that your devices can be moving around, okay, with the speed less than 80 kilometers per hour. Because for most of the IoT network, we are expecting the application or the terminal is more on static in a place like the smart meter. After you install it, the meter will not moving around. So it's more on fixed locations. But for the IoT, because it's using the mobile network, so they can support for the mobility with the speed less than 80 kilometers per hour. So now, other than the NB-IoT, another options will be the EMTC. In fact, EMTC is the wireless IoT solutions proposed by Ericsson. So it's telecommunications vendor, okay, Ericsson. So he's the one that proposed on this EMTC. And this EMTC, the solutions mainly is to deploy IoT network based on the existing LTE access as well. Okay, just that for this EMTC, they are suitable if your applications require higher speed, which is around 1 megabit per second. Okay. Because normally for a normal IoT network, we are just expecting the devices to report a very small size packet, maybe like 10 kilobit per second is enough, or 50 kilobit per second. But if your applications required higher speed rate, then EMTC will be more suitable because it can support up to 1 megabit per second. And power consumption will be small as well. Just that the disadvantage will be the coverage will be smaller because it's targeting for the speed and also the capacity. So this one will be another applications that required on this higher rate. Okay. So and another good thing about the EMTC will be it also supports for the voice communications. Okay. Compared to the others, it's mainly support for the data communications. Okay. Other than the EMTC, and then the next one that we have will be the comparison. So you might think that okay, since that I have so many options for the LPWA, so how should I choose which one will be more suitable? Okay, so in this table will be very good, will be useful for you if you like to compare among these four LPWA technology. Okay, first thing we can have a look from their frequency band. Okay, so for the frequency band, Sigfox, LoRa, and Sigfox and LoRa, both of them will use the unlicensed frequency band, while for the NB-IoT and the EMTC, they will use the licensed frequency band. The main reason is they deploy on top of the LTE network. Both of them, they are on top of the LTE network, okay, to deploy the NB-IoT or the EMTC. Meaning that you must have the LTE network in order to deploy your NB-IoT or the EMTC. That's why they are using the licensed frequency band. Okay. If we compare from the transmissions rate, Sigfox can support up to like 100 bit per second. LoRa will be around 0.3 to 5 kilobit per second, while for the NB-IoT will be less than 250 kilobit per second. Okay, if you are required higher transmissions rate than EMTC, because EMTC can support up to 1 megabit per second. Okay, while for the distance, the distance over here will be meanings. Okay, maybe some of you are not from the telecommunications background. So when we mention about the distance, okay, it's referred to when I deploy the base stations or the transmitting antenna for this technology. Okay, so what's the distance that can achieve? Okay, example, if I deploy with the Sigfox, okay, the distance they can cover, the signals can go up to like 50 kilometers. So that's the distance. For example, you are at this place. So the distance from the base stations or the transmitter, okay, can be up to 50 kilometers. Okay, if you are using LoRa or the NB-IoT, their distance will be slightly lesser compared to the Sigfox, will be around 20 kilometers. Okay, and then for the EMTC will be lesser, around 2 kilometers. Because for the EMTC, they focus more for the higher transmissions rate. Therefore, their typical distance will be slightly lesser, okay, compared to the others technology. Okay, in fact, for the Sigfox, if you refer to the official statements, okay, some of the applications that can achieve up to like 1,000 kilometers. Okay, over here will be just a typical or general applications. For the Sigfox will be target up to 50 kilometers. Okay, so for the application scenario, they will have like the smart home appliance, okay, smart electricity meter. So Sigfox will be suitable for these applications. Okay, of course, it's not limited. Here is just like generally, Sigfox is deployed for the smart home applications and the smart meter. Okay. While for the LoRa, mainly we use in the smart agriculture. Like example, we can use it to detect the humidity level, the temperatures, the water level, whether should we trigger the watering for the plant. So that one is part of the agriculture. Another one be the intelligence building and also some of the logistic tracking. Okay. Well, for the NB-IoT, okay, since the NB-IoT they are deployed together with the LTE network. Okay, if your current the operator they can provide like up to 95 or 98% coverage of your entire uh, nations wide, that the NB-IoT will be a good solution if the company would like to deploy for the IoT solutions, because this one can use like your water meters, can be used in the parking scenario, okay, pet trackings, garbage disposals, or the smoke alarms, and also some of the retail services as well. Okay, and for the EMTCs like since that it can use to transmit with the higher transmission rate, like the shared bicycles, pet collar, or the pole smart elevator will be the main applications for the EMTC. So this will be you can analyze on your applications and what is their requirements before we go to or decide which technology is suitable to deploy for your IoT network. Okay, of course, it's not limited to here, but mainly will be we need to know about your requirements and the purpose that we like to achieve. Okay, so over here will be a reference for you in terms of the comparison between different LPWA technologies. Another one, okay, so you might, after we put it into the table, another one, if you like to see it in another dimensions, we can compare between the data rate and also the coverage. Okay, because this is very important when mentions about the IoT applications. Because for the IoT applications, we are not only targeting for all the devices to connect it, but we also need to know about our cost to deploy, okay, for these applications. So if your concerns on the coverage is very important, then you can see that, okay, the LPWA will be a good solution for the IoT network, okay, because it generally can cover up to 10 kilometers for the coverage. Just that for the LPWA, they are more suitable if your terminals transmit with a small packet size. Okay, that's why it will suggest to use this LPWA in a scenario like the smart meter or some of the environmental monitoring scenario. Okay, if you are targeting for the like very short range and then small data rate, then you can target for a small packet and a short range like the Z-Wave or the Zigbee. Okay. If you would like to use with a higher speed rate, but just for a shorter range, you might not require, I know that up to 10 kilometer. I just maybe just less than like 100 meter. You can use like the Wi-Fi solutions, okay, because the ones or the Bluetooth to achieve for the higher rate but shorter distance. Okay. Another one will be if we are targeting for if we want to get a balance between the data rate and the same time is the coverage, then you can target like LTE network or the 5G networks, which is like will be very popular in current days, like to use for the video surveillance, IOV, or the smart healthcare, or we can use it in like this smart factory as well. So this one will be target if you required a very high data rate and at the same time your coverage. Okay, so then we can go to the options like the LTE or the 5G. Okay, in some of the applications, like they might not required to a very high data rate, they just require some medium speed, then we can go for the 3G options or the LTE with the UE category 1. Okay. For the UE category 1, 2, 3, 4, that one it just refers to your phone capability, meaning that when you're having the higher category, your phone is more powerful. I believe you check on your phone spec before when you purchase a phone. So it's like you normally will see, okay, your phones, okay, what's the function they support, okay, what's the maximum speed they can go, okay, and that's what's the frequency range that can support. So that one refer to the phone capability. So for the phone capability, we are refer it as the category, meaning that if you're having the higher category like 3 or 4, you are more powerful compared to the category 1. Okay. Okay, and then followed by in like maybe in 10 years ago, you might notice that in some of the area, they also have the smart meter, especially for the water meters, but the ones is more on the very low data rate, okay, and they implement it using the GSM network, okay. Because for the GSM network, we need to admit that they provide a very good coverage and very stable. Okay, so that one in some of the country, in fact, they already deployed the IoT based on the 2G network, especially like the meter reading. Okay, in some of the rural area, they can just report on the meter usage, the readings to the water companies through the GSM network. Okay, so 2G is also referred as the GSM. Okay, so over here will be introductions, okay, or comparison. Okay, which wireless communication we should use when we want to deploy for the IoT network. Okay, I hope this one will be useful for you. Okay, based on the data rate and also the coverage. Of course, for the company, we also need to consider about the deployment cost as well. Okay, now we'll go to the next part, which is about the IoT application. Okay, just now we discussed, like we have different IoT concept we can use. We have the options whether through the mobile network, fixed network, or I can using the cheaper solution, which is the LPWA. Okay, so for all this network or the technology actually is to realize the IoT applications. Okay, in today we'll discuss one of the IoT applications, which is about the smart lighting or the street lamp. Okay. Okay. First things we have looks. Okay. Application scenario of this smart lighting. Okay. You might not really think it's very important, but when we go to the calculate on the cost, you will see that it's very important in nowadays. Okay, because this street light, like we need to cover it for the common road, square park, tunnels, expressway, building, or some of the scenic spots. Okay, in fact, the cost that involved for these lightings is very high. It will out of your expectations. Okay, so first things we have looked on the pain points. Okay, commonly the problem that we face in this urban, the street light or the public lighting will be the street lamps. Sometimes is they are not sensitive to the weather conditions. Like in the some extreme scenario, they might not able to detect it and then to adopt. Okay, another one will be the high voltage. Okay, this high voltage of this street lamp actually it will causing a very high energy consumptions. In fact, it's a cost to a, I can say it's a cost towards a country. Okay, and then another one will be the maintenance part, because for the inspections for this street lamp, actually sometimes it will use up or occupy a lot of the manpower. Okay, and then in some of the area, you notice that it's very difficult to locate the problems. Like you might notice that sometimes it's like after you make the complaint, the problem is not solved immediately because they need time to arrange the manpowers to identify where's the problems. Okay, it will take time to solve the or locate on the street light problems or the public lighting. Okay, so with the current economy and the social developments, in fact, the public lightings becomes significantly important um, in our daily life, okay, or in the modernizations. Okay, for example, in your municipal parks, landscape, square park, or the community schools. In fact, they play an importance. You might not really notice it, but in fact, they are very important, and we can't live without them because they are providing us the all the lightings. Okay, okay. Example in the municipal parks, like sometimes the complaints we might have like poor management, okay, or they can have the difficult surveillance on this scenario, or another things is like causing some energy wastings, okay, or the security risk due to like some you have the lighting facilities damage. Okay, another one will be difficult to locate on the problems because it might scatter in different area. So it's very challenging or the time consuming to identify on the problems. Okay, and that sometimes due to like the some intelligence, so we are not able to control or manage it in a better way. Okay, so this is like the common problems that we face, and now let's have a look. Okay, why we say this urban public lighting is very important. In fact, if we break it down, you'll notice that the power consumptions of the street lamps, they are increased over the year. Okay, and based on the data from the 1997, based on these studies up to 2014, okay, they notice that your total power consumptions actually is very high, up to like 38.46% of your total power consumptions nationwide. Okay, so for this problem will be like, because it need to provide the lightings we need to provide towards a wide area, okay, a massive. And this one is like you keep growing because now the app is developed, and that you need to provide this public lighting. Okay, another one will be the higher service assurance requirements. Okay, growing power consumptions over the years, and then on the higher requirements from the governments on the energy conservations and the emissions reductions. Okay, another one will be the lack of the unified regional managements and the supervisions. Okay, and the next one will be the single mode smart lighting constructions and slow progress. So this is all the challenges that we face in the urban public lighting. Okay, so now is when we go to the industrial problems and the requirements based on the challenges that we face. So if we convert it to the industrial problems and the requirements, we can break it down like we require, it use up a very high maintenance cost, and sometimes the inventory is unknown. We don't know what's the device quantity and what is their status, running status. And for the energy conservations, because it's very difficult to monitor, sometimes you might not deploy it effectively and not able to manage. Okay, and if based on the study, sometimes we notice some contradicts between the on-demand urban lighting and the actual lighting plan. And based on the overall the business model, investments, operation, and the service model, in fact, they are quite outdated compared to the modern days requirements. Okay, and for these lighting management departments, in fact, because they they have a less visibility into these managements, so sometimes lead to them have lesser importance role when go to managing on all these utilities. Okay, so before we go to the details, we have looked on one of the common street lamp control. I believe you notice it sometimes on the street. You might notice it. It's a small cabinet. In fact, for this small cabinet, it's also called as a group control, where this is a power distribution box to configure, to control on the street lamps and to supply the power. Okay, so normally it will be around 100 street lamps will require one control, group control. Okay, so we can switch control on the switch for the street lamp and also the providing the power. Okay. So this is just now is more on giving you the ideas like the problem or the challenges that we face in the this public lightings or the street lamps. So now we have look how can we improve or solve the problems that face in the industry. Okay. Now let's have a look on the solutions. Okay, for the smart lighting solutions architecture, we can divide them into three parts. First one will be the group control solutions. Another one will be the two-hop individual control solutions. And the third will be one-hop individual control solutions. The group control solutions will be all the street lamp will be managed by one central controller, which is just now I mentioned, we have one group controller. Okay. While for the second options, two-hop individual control solution will be deployed through the IoT. And this IoT, we are using the short range like the Zigbee or the ELT to communicate, to transmit their signals to one controller before they send back to their platform. Okay. And for the third, one-hop individual control solutions, we can using the NB-IoT. Okay, we will integrate the chipsets inside the street lamps so that they can transmit the signals back to the IoT platform through the NB-IoT. So we'll have these three options to deploy for these smart lighting solutions. Okay. Of course, for the operator point of view, if this network is used by is deployed by the operator, they will consider for the two-hop or the single-hop or the one-hop individual control solutions because they can base on their current network to deploy on it. Okay, LPWA network will be prefer for the one-hop solutions. Okay, but depends on the depends on their network coverage requirements. Okay, if they are required wider coverage, then NB-IoT will be one of the options for the operator to deploy this NB-IoT for the smart lighting solutions. Okay, and for the two-hop individual control solutions, in fact, we just deployed the street lamp with the embedded controller, and they will report this information to one centralized controller, or we call as the IoT gateway. And from this IoT gateway, he will go to the report through your LT network or the UMTS to your one agile controller and towards the applications like the street lamp management system. If for the one-hop individual control solutions will be much more simple because we can just embed the controller inside the street lamp and report through the IoT network directly towards your platform. So it will be simplified compared to the dual hop. Okay. And for the one-hop individual control solutions architectures, we can break it down like based on the end-to-end network architecture, first layer sensing layer, and then followed by the network layer, platform, and the applications layer. Okay, so for all the street lamps, they will convert into the smart street lamp where they will install with one this RTU inside all your street lamp so that it can report the signals to your NB-IoT network, and then these informations will be fed to your IoT platform. One of the IoT platform provided by Huawei will be the Oceans Connect, and from this Ocean Connect, we can link the data to the applications layer. Example, public cloud. Okay, so for your street lamp, when we want to convert it into a smart street lamp, in fact, they can provide a multifunctional lamp pole. Okay, it's not only a smart street lamp, but they will embed it with multiple functions. Okay, other than first one, smart lighting. Okay, where they install with the sensors for the light. Okay, then we can deploy together with it as well, like the weather and environment monitoring. We can have the video surveillance, okay, and at the same time can provide the wireless towards the like the smart city wireless provide a wireless service to the public, and then followed by the information release and the interactions board. Okay, and the urban IoT mainly like for IOV or some of the monitoring as well. And then we can embed it with the one-click police callings for the emergency and also for the smart charging part. We know that now the electric car is getting more popular, or there's another option will be they can embed it together with the smart charging part. Okay. And for all the terminal and the controller that they are embedded together can be example, smart monitoring terminal, and also the individual controller. Over here is just an example for you for the reference, like type of the terminal and the controller that we can install inside your street lamp. Okay. So for the integrated installations, we will integrate one individual controller as well as the power module into your smart street lamp. Okay, so that we can achieve, okay, for the energy conservations, and also we can provide these informations to manage through the IoT network. Okay, so this is just some example for the smart street lamp. Okay. And most important will be after all this information is report to your IoT platform, we can manage it from your applications so that you can have a visualized management, like show it in the pictures. I know that my exact locations for all my street lamp. Okay, and at the same time, you can refer to the right hand side. I can know that how many of the street lamp currently is faulty. Okay, example this case, 2 of them are faulty, so they are in the gray color. And then I know that, okay, currently I need to send someone to repair. Okay, compared to the nowadays, we are waiting for the public to make a complaint, then we only know that, okay, there is some failure at this part. Okay, so now after we have the IoT network, then we can have the visibility about our infra. Okay, so for this case will be the street lamps. So we know that there are some faulty area, then we can send the teams to repair it. Okay, so we can get the statistics information. We also can get the update, okay, the latest situations, and important will be the current configurations or the setting. Okay, what's their connections that use, and then their exact locations. Okay, over here will be one of the example for this smart lighting. So based on each of the lamp pole, they will integrate together like with the QR code, and each of them will come with the like their identity, the ID, and then the location. So they'll have number, coordinate, and then locations, ownerships, and also the administrative area. Okay, so all this information they can fit to the GIS for the managing your urban lighting. So for the smart centralized control, then we can like manage on your street light or whether power on off remotely. Okay, so this one is like we can manage it based on the time or the location, like longitude, latitude control, illuminations control, or due to some contingency plans, okay, or some emergency. And at the same time, we also can monitor for the operations like the voltage, current voltage and the current usage, and other sensings like whether we need to adjust on the power, the water level, whether is there any flood, okay, other monitoring devices, and also the cabinet door. Okay, so for the single lamp energy conservation management mainly is like we want the street lamp have that intelligence to control, okay, on their power consumptions. Okay, but for example, in some area, if I'm not required up to that high power, they can adjust, okay, on the illuminations. For example, in the pictures, the LED illuminations before and after. So this one is like we can through the system to adjust on the this lamp, okay, or we call the smart light adjustments, so that we can averagely we can save up on the power consumptions by this street lamp. Okay, in the long run, it will be a very effective. Uh, it will be much more effective and cost saving. Okay, so from this is what will be like more for we can have the specific monitoring and control, precise the positionings of the lamp fob, and also reduce on the cost, whether it's the inspections cost or the operations cost. Okay. So from the this conservation management, we also can know about the report, can say in the real time, because once there is faulty, detect faulty lamp, street lamps, then we'll get the report like light source malfunctions, the locations, and then they have the information, the time. So this one will be much more easy to manage or maintain by the operations team. Okay. Another good thing will be once we can fit all the data to the applications, then we can have the flexibility to manage it like through your mobile apps. Okay, so this will be similar applications like towards the smart home. We can adjust control on our home appliances. So here we can like whether you want to switching the light on, okay, what's the current voltage consumptions, the areas, okay, the mode, okay, whether you want to dim the power or dim the light. Okay, so this one will be become an application and is very easily managed through your phone. Okay. So for the core value of the overall smart lighting will be we want to refine the management, smarter service, and very important will be the energy conservations and the emissions reductions. So that's the three main things that we like to achieve for the smart lighting. And over here, we have one simple case study. Okay, in fact, this one is implemented in the Czech Republic. For example, based on the study, they noticed that the lighting consumption is 19% out of their total power consumption nationwide. Okay, so which is a big portion. Okay, uh, for the total power consumptions. Okay, so to to meet on the Czech Republic governments, they have their visions to build on the smart cities, and their target on reducing for these power consumptions, where smart lighting will become in important role when defining in the smart city solutions. Okay, so in the CZ group, which is the largest energy producer in the East and the Central Europe. So it's also the company that provides the street light for the Czech Republic. Okay, so once the government's having these visions or defining on this target, so this also trigger for the CZ group to transform itself to provide a more effective, okay, a more effective way and cost effective way on providing all this street lamp. Okay, so this one will be they also have is a opportunity for them to transform and save the energy and also reduce on their overall OPEX. Okay. And in this during this CZ group during that transformation, so Huawei also is providing like the Huawei Lighting LT for this Czech smart city solutions. So inside this solution will be providing using a short range, okay, or the 6 low pan, okay, solutions with the embedded MCU in the street lamp. Okay, so they were providing the sensor and controller. So through the 6 low pan to report the signals to the gateway, and from this gateway or the Agile IoT gateway, it will connect through the LTE network or the 3G network, okay, to their management controller. So this management controller can be something like their platform, and from this platform, they fit to their application system so that they can manage on all the strip lamp remotely and more effectively. Okay, so for today, we have discussed for the a basic concept about the IoT and also the options of this LPWA technology we can use in the IoT network. Okay, we also discussed about the pain points faced in the traditional lighting solutions and what is the architectures, features, and the value of the smart lighting solutions. Okay, and a simple smart lighting case study that in the Czech Republic. Okay. Okay, thank you everyone. Okay, now it will be open for you. If you have any questions, then you can leave your questions in the chat. Okay, maybe we wait for a while to see if you have any questions related to this IoT. Okay, just feel free to leave your questions. Okay, so I hope today you all enjoy for these training sessions. Okay, although it's just a short trainings, but I hope you get the overall ideas about this IoT concepts and what is the meanings of this LPWA as the related applications. Okay, once again, I would like to take this opportunity to thank TDRA for organizing this event and of course all of you that taking your time to attend these online trainings. Okay, I hope we'll see each other again in the futures and take care everyone and have a nice day. Thank you very much for attending this online trainings.